Hello, everybody, and good morning, good evening, and good afternoon. And thank you for joining the first episode of Going Meta in 2025. So I think it's still good to say Happy New Year, everybody. I hope you know it's maybe little PSA. It's Tuesday. Still in this fluffy world. Maybe it's just coming back to work. Maybe just this week. Maybe early last week with all the New Year celebrations. Still, what time is it? What day is it? Where is everything? And what am I doing with my life? So you're at the right place, I think.
I was going to say that's a good sign. It means that you have had a proper disconnection over the Christmas break or the holidays.
Yeah, exactly. I hope you had the same, Jesus.
Yeah. No, that was great. That's great. But we're now back full of energy and so ready to kick off the Going Metas for 25. So yeah, looking forward to this session with probably again the longest title in our history. We should one day publish our discussions for the episode on how we come up with our trouble, and it's getting more and more complicated.
It is, and there's this limit also with characters. So in YouTube and on LinkedIn, you are not allowed to do. I think YouTube is a little bit more lenient with you. So I think you have 100 characters. LinkedIn doesn't give you more than, I think, 75 or something. So you, if you want to have this season 2 episode X in there, it becomes, you waste so much characters. so we add that. But this is a fun title. I think we have a little Lord of the Rings reference. So
we're going to keep working on what we've been covering over the last few months, probably the last few episodes, which is of course, going in the direction of GraphRAG, but specifically in the knowledge graph construction part. And because we've covered separately building it out of unstructured data, and we look at the blueprints, we look at doing it with the LLM knowledge graph builder in a no code fashion, then we did it programmatically with the GraphRAG package. We did many months ago construction also from structured data in the previous season. And I thought it would be a good idea to combine the two, because the reality is, hey, data comes from many different sources. Some data is structured, some data is unstructured. That's what we mean by mixed data. And yes, I mean, we're going to show how we can drive the construction by using the same ontology that drives one will drive the other, and we'll see how we will combine the different approaches if we have the time and everything works as expected. That's the that kind of reflects a little bit more the reality of the enterprise, right? Where data comes from different sources, but still driven by a common understanding of the domain, by a common enterprise ontology, by a common understanding. A common canonical model, if we want to call it like that. So that's the plan. That's what's behind this super long title. But I don't know if we have any announcements beginning of the year, or should we just get started?
We can just get started. I think the only announcement, as always, is from my side. If you have questions, if you have comments during the episode, please just type it in chat. For everybody watching on LinkedIn, I cannot directly reply sometimes, but I'll see your question, I see your comments. So thank you very much for them all the time. If you like this episode and you're watching this on YouTube, if you give it a thumbs up, that would be great. So then more people can also see and hear about it, because that's how YouTube works. And if you have any ideas, any concepts, any suggestions for future episodes, I would say YouTube is probably also the best place. If you put a comment in or LinkedIn, either works. I think if you put a comment down the video and give us your thoughts and let us know if something is in your mind, it would be a good episode for the future. Then we'll always have a look out for those, and hopefully we can cover something you have suggested in the future. But yeah, I think with that we can dive in.
Excellent. So that's the I guess you can see my screen. Let me know if there's anything. I've heard or I've read some comments on YouTube, people complaining about the quality or whether it's readable, please do let us know if it's not readable, because that of course we're going to be sharing as always all the content, but probably it's less exciting to follow if we can't read what's on the screen. But anyway, we started by fitting the whole title in the slide, and it's this idea that I was describing a minute ago, and I've kind of already told the story, right? So I in one of the sketches that I come up with as I think of the content of the episode, the idea is what I was describing before, right? So we have data in unstructured form, and these are the PDFs that we've used over the episodes that will be data where it's it's meant for human consumption in a way. So it's documents that are free text and that therefore are not as easy as to get structure out of as what we call structured data, which are typically CSV files or even databases with the proper structure, in rows and columns, where we can be more specific and actually ETL the data into the graph. Now, what's interesting is that often we have of course, we put the data into the graph not because it's cool, but because we're trying to solve some problem. And in order to solve the problem, we normally will come up with a description, with a model, with a graph model that we refer to as an ontology. And this ontology is going to be the kind of the target model, the driver for both types of data sources. And that's what we're going to be showing today. So this box in the middle is actually a combination of things that we're going to see in a minute. And it's kind of a unified block or module, if we want to call it like that will consume both types of data, but it's driven by the same ontology and ultimately feeds the knowledge graph in Neo4j. Now, so I guess, like I said, that combines some bits that we've done in previous episodes and put it all together in one single experiment. And when we refer to ontologies, I always want to insist, and this was my way of capturing this idea. An ontology is a formal machine-readable representation of a domain. So you can see that taking different shapes. The most basic ontology will be probably a schema, a description of the entities or the categories in your domain with relationships between them, with which attributes do they have. It can be richer when we introduce a taxonomical organization. It can become even richer when we introduce actions, constraints. All this has been covered, and I refer to previous episodes where we'll look at so many variants of all that. But the idea is that very often we'll have an ontology represented or serialized using the W3C standards, right? That's what we're going to be using today, and we have used it so many times. So there's sort of a standard way of serializing ontologies. That's not necessarily the only starting point, as we're going to show at the end. Some people might say, and we get that question very often, it's like, hey, you always start with these Protege, which is the open source, the public, the free tool to create and manage ontologies. But what if I don't want to create an ontology using Protege? I want to use it with my model catalog in Neo4j. Well, that's why I put this kind of circle there, because what we refer to an ontology can take different kind of incarnations. Yes, there's the W3C standard approach, which some of us are familiar with, but from there on, and because an ontology is a machine-readable representation of it, it's something that we can programmatically transform into many other things. And again, parts of this has been shown over the episodes, but we'll see how, given an ontology in a W3C serialization, that is OWL, RDFS formats, vocabularies, we're going to be able to import them in the model catalog in Neo4j, which is something that I'm pretty excited about, showing, because it's one of these things that has been added to our Aura console, and that has gone a bit quiet. I don't know if have you heard about the model catalog, Alex? So now you can manage in your Aura console a collection of models, and that's pretty cool, because it's something that I just realized, talking to Michael a few weeks ago, and I thought it's worth talking more about it and showing it. And yes, from a W3C ontology, you're going to be able to create a model. We've talked many times about these ideas from some domains, from some industries. There are standard vocabularies. Let's not reinvent the wheel. Let's reuse that, and that makes perfect sense. So that's great. We're going to show that, and from there, you see on the left-hand side, from the model catalog, from the Aura console, we will be able to do the structured data input. That's one of the ways in which we can do it, as we're going to show in a minute. You can map your ontology to the source data, basically drag and drop, indicate which fields in which tables or in which files map to specific properties, and it will take care of all the ingestion and the writing to the graph. Now, if we continue the circle, and that's more recent, we know that we have different tools to import unstructured data and build a knowledge graph out of it. And the one that we used more recently was the GraphRAG package, the Python GraphRAG package from Neo4j. I believe that's the last episode.
That was the last episode, exactly. Yeah.
Yeah, so that would be episode 4 in this season, right? So we covered there how, from a W3C standard ontology, you could generate the kind of guardrail. So I don't know how we called it, like model that will drive the entity extraction or the model extraction from the unstructured data, from the PDFs, from the CSV, well, not CSVs, from the text files, and that would drive the construction of the knowledge graph. So and then the third leg of this kind of circle is, what if, like I was saying before, I'm not starting from a W3C standard representation. I just have created my model in my model catalog in Neo4j. Can I do that? Of course you can. You can, of course, generate and feed the GraphRAG model. But not only that, you can also go back and generate a W3C standard representation out of it. So again, all this to say that when we talk about ontology, I mean, this concept, this notion of an ontology can take multiple different shapes, covering the most standard for some people, but taking many different angles. And I want to kind of, I hate the word demystify, because when we have to demystify it, because before we have mystified it, which is stupid in the first place. But I want to make it simple and make people understand that creating an ontology and using it is a lot simpler than what we think sometimes. So I hope this introduction makes a bit sense and gives a bit of context on what we're going to be trying, because there's not much more as an introduction. I'm going to jump into the code if that's okay. If there's no other questions, what do you say, Alex?
I don't see other questions, no, and I think it's a good point about the model catalog. I think that's been relatively recently added to Neo4j Aura. I indeed haven't seen it myself directly, so I think it's a good. It's also a great reminder of to everybody, basically, that there is constantly updates and new features being added to the Aura interface. So if you haven't looked at it in a while and are wondering what is this all about, then check it out. Jesus will show us a little bit as well today. So I think it's a good good overview. But yeah, other than that, no questions. If anybody has any, please let us know. But I think it's very clear today.
Cool, excellent. So yeah, this is my Aura console, and all we have to do is go to the input section, and you will see how you have, well, the usual data sources and input jobs, but now we have the graph models, and I have a collection of them that I've been playing with. I have an art model, a test, one that I call test. I can give them a name, and you will have a bunch of the usual description that you can create. You can do it manually, as I'm not going to do this today, but as you know, you can just start creating nodes, then relationships. You can give nodes, labels. You can say this is a person. Person works at a company, and so on and so forth. And the same with relationships, right? You can say works for. And then for each of them, you can add properties, etc., right? So nothing new here. So that would be the name of the person, etc., And once you're done, you see that it shows up in our as a new graph model in your catalog. And you can give it a name that's meaningful. So in this case, maybe we can say, I don't know, enterprise, whatever. So you give it a name, and you have it in your catalog, and then you can use it later on if you want to drive the data ingestion, the structured data ingestion, which is the one that we drive from Aura. So that is a catalog. It's as simple as that. But what's great, and what we're going to show today, is that, well, we can of course create it manually, like we've been able to do for a while. But we're going to be able to also, if we remember the circle, starting from an ontology serialized as OWL in any of the W3C standards, we're going to be able to populate these kind of graph models without having to create it ourselves. And like this, guaranteeing that we're ontology driven, and the ARM graph in knowledge graph in Neo4j is perfectly aligned with the ontology, with all the good things that come with that, which is enabling interoperability, etc., etc. So not going to go over all these elements because we've talked about this many, many times. Yep. So yeah, if I go to, let me go to these. Well, we've seen it many times, so I won't spend a lot of time here. But this is Project, which is the modeling environment where you can create ontologies, and I'm describing a well, let's call it a sales domain. That's why I've called my ontology sales ontology. Maybe I'm going to bring briefly, because I'm going to show the data that I'm going to be working on, and also that gives people an idea of what they're going to be finding. Give me just 1 second. Oh, what they're going to be finding. I was saying in GitHub in a few minutes once I check everything in. So let me quickly bring my VS Code here, and that probably is the easiest way to show what we have in our data directory. So the data that I'm going to be working on is sales data. So we'll have structured data that I've called CRM, and this is purchases, customers, and the locations where they are. So 3 tables, 3 CSV files that I'm going to load using kind of an ETL sort of approach with the data importer tool. But then we have some unstructured data. So for these customers, for these purchases, we have a collection of credit notes. Credit notes is refunds, right? So this is, of course, generated data, but the PDFs look something like this. So this is the company, Lime Electronics, and a credit note has an ID, it has a date. I mean, it's relatively structured, but you see it's kind of not as structured as a CSV file. So we have who's the beneficiary of the credit. So it's a refund because there was a defect on the product, and that's the amount of the refund. It references a particular purchase, which is how that's going to link to the other data. So you can think of these as unstructured data that comes to the enterprise from a different source, and it comes in a format that we're going to need to align in a knowledge graph. And well, we have, like I said, the branch that generates the refund, the credit note, and the customer that's the beneficiary of it. So that's pretty much the structure of it. Make sense?
Yep.
So these are the credit notes. We have a collection of them, not many, just a dozen here. And the other source of structured data, we're going to see that the purchases refer to the customer, but also the product, and we have some product descriptions. And again, product descriptions, we can think of it as a catalog, and I don't know. So we can take as for example, this is a smart speaker, and again, unstructured data. We have the details; it's all generated, so no worries about confidentiality or reuse of any kind. So there's the details of the product in question, the key features, some specifications, and what's in the box. So yeah, a PDF, a random PDF that has some additional information about the product that we're going to be referring to in the purchases. So that's the data that we have. Now, given that that's our domain, some of that data is structured, some of that is unstructured. I'm going to create an ontology that covers it all. Right, so we are going to have a number of concepts. For example, products. We're going to have customers. We're going to have purchases. We're going to have locations. We're going to have credit notes. We're going to have stores, and they are going to be related to each other with what we call in the OWL world space with object properties, which are the relationships in in Neo4j's world. And you see that how, for example, by customer is a relationship that connects a purchase to the customer. So a purchase is carried out by a customer. A purchase is of a product. So if you go to of product, it connects the purchase with the product, and so on and so forth. A refund for is connecting a credit note to a purchase. So all the ideas that we have been describing, visually on the source data is what we capture in this ontology. And finally, we have the data properties similarly, right? So for example, for a customer, we have a customer ID. The domain, as always, is the customer. The range is the data type in this case, because these are attributes or properties. It's a string, and so on and so forth. So we have the email for a customer. We have the customer name and all the others. So that's the ontology that I've created, and I've saved the ontology. This ontology that I've created with WebProdigy is back in my repository under the ontology section in the sales ontology. So this would be the RDF serialization that's literally produced by WebProdigy. And we have all the elements that we've just seen, right? So the product name, the product code, the categories, the relationships, etc., etc. Good. So we have that. We have that ontology, right? Now, what I've done for convenience, so that I don't have to read from files, is put it in a mini, in a local. Let's go back here, in a local HTTP server. So that's running locally, as you can see. And we have the ontology that I've just created, the sales ontology. And I've also copied the insurance ontology, just to show an additional example and some others. Because, of course, this is valid for any ontology that you may want to use. The insurance ontology, for those of you who are not familiar with it, is the ontology that the Data.World team used in the benchmark that they published over a year ago, and that we analyzed in great detail in one of our episodes. And they published it in a GitHub repository. So what I've done is I've copied it. If you go to these, you have the ontology. And this insurance ontology is the one that I've literally copied locally just for the test. But it doesn't, I didn't need to do that, because you can use public ontologies. I mean, what I wanted to show is that, and I'll share the code and how that works, but to make it more palatable and more easy to follow, I've created a small Streamlit application that I have I'm running locally. And all I have to pass to this ontology, remember that what we're doing is I have an ontology serialized as any of the W3C standards in OWL or RDFS. So give it to me, and I'm going to generate a model that I can import in my Aura model catalog. So all I have to pass is the URL of the ontology. So in our case, just for the test, let's use the insurance one, which I didn't create, but I've taken literally from their GitHub repository. So if I copy the URL and I pass it to my mini app, so I pass this, and the serialization is turtle. What this is going to do is going to scan the ontology definition and list all the classes that are there. So there's an agent, catastrophe, claim, expense, all these sort of insurance concepts. The reason why I list those is because you might not want to import them all. I mean, you always have the option, and you have these all classes, but you might say, hey, I just want to import the agent, or I might just want to import the agent and the policy. Well, so it's up to you, right? In my case, I'm going to use all the classes. And you see that behind the scenes, what this code is doing is it's processing it, and it's telling me, hey, I've detected that there's an expense reserve that has this property, there's no relations, there's some others. So it's basically scanning the ontology and producing a model that I can now download. And I just need to click here. And it's been downloaded under insurance one, because it might be an older version. So all I have to do is, this is a JSON format that I can just come to Aura and say, okay, I'm going to create a new graph model, and I'm going to not create it, I'm going to open it from the file. And the one I've just downloaded is this insurance one. You see today at 4:24 right now. I open it, and boom. So we have, I still have to work a little bit on the layout, because it kind of puts things in a bit of an odd fashion, but let me reshape it a little bit. And I'm going to zoom to make it readable. Let's put this here, and let's let me take a bit more space. And you see that all the elements in my ontology are there, and I didn't have to create them. And you have a policy, and all the properties the attributes have been imported, policy effective date, expiration date, etc., etc. So a pretty convenient way of reusing the ontology. I'm literally reusing it. So this is exactly the collection of entities, relationships, and attributes defined in the data world ontology. So if I were to take the source files, which they provide as well, and use them here, I could replicate exactly the same graph, perfectly aligned with the ontology, right? So
yeah,
that's the so I can go back to my graph models, and I can give these a title again. So this I can rename and call it, for example, insurance. There you go. So, and I keep adding to my collection. So I'm not going to use this now, but it's again, and this applies to literally any ontology. And I had as an example, because I remember that was, I don't know if it was the last one, where someone asked, why did you not use that public ontology, the Getty?
yes, that was, yeah.
And I complained that it's so hard to find them. I've been trying to do some research, and I've found a couple of them, not many. It's still pretty hard. But there's this building ontology, and well, this is the serialization. But if you know, if you can read the description, that's the URL. And basically it describes, as you can see, elements related to the construction industry, right? So you see things like, I don't know if it's readable, but there's a building, there's a space or an apartment or a story. There's elements like a window, etc., etc. So there's so many things there. So, and this is the serialization. So I can take that URL again and go to my mini app and apply exactly the same logic. So if I copy this URL, now it's going to rescan this, and we have a new collection of classes from the ontology, and I can come and select. It's just another example. Just wanted to show that you can, for example, take a building. You can take what was it, an element, and I don't know, space, just randomly some of those. So I could pick all of them, of course, like I did before, but once I find the ones that are relevant to me, and you see how they're being parsed and that's being extracted, I can download the model, and that's been saved as ontology.json. I can now come to my catalog, create a new one, and say, okay, import, open the model that's called ontology.json. If I import it, boom, I have my 3 things there. Oops, I didn't mean to do that. I've dragged it. So you see how it basically takes the ontology as it's been defined, and I didn't need to do anything. So the space comes with the max and min occupants, the building with the altitude, latitude, all the attributes that were defined in the ontology, etc., etc. So very convenient way to like I say, to reuse ontologies and have them drive both the structured and unstructured data, as we're going to see in a minute. But I thought it was worth, let's call these, again, I can go back to my models and call these, oops, graph models. I wanted to rename it, and this might be the building.
That's pretty cool. And that's a very, easy way of getting started when you have. Sometimes the modeling process is a hard one, and you don't know how to define which node and what relationship. And if you have a starting point like this that is already defined, you have just to throw in the data basically to it, and then it slots in nicely, and then you create almost by it's more complicated than that, I know, but it's almost automatically or magically it creates the graph for you.
Absolutely, yeah. And here, of course, Alex, we are kind of simplifying things to fit it in like 1 hour session. But of course, behind the scenes, I mean, whoever's doing that will go and do what I did, right? Do some research and say, hey, I want to solve a problem in the construction, in the building industry. So is there other existing models out there? And they will go and do some research, and they might find relevant bits and say, oh, that ontology is good, but it doesn't cover all I need. So I'm I'm probably like, just like you're saying, right? So I'm going to import it, but then extend it with some elements because of space, in my case, I want to connect it to X, Y, and Z, right? So yes, this is a starting point that gets you aligned with standards. So not only does you're reusing something that other people have built and published, but also you're enabling interoperability. I mean, your model is perfectly aligned with an ontology that then, if there's a need for exposing, for sharing, for publishing data. And again, we're not going to cover that today, but this is in previous episodes. You can create an endpoint where the data in your Neo4j knowledge graph gets serialized as RDF, and you can perfectly align with the ontology. So any RDF consuming application or any API that you create will be perfectly aligned with the ontology in question. So there's a lot of benefits. So not only you're reusing and reinventing the wheel, but you're enabling interoperability, which is another added value when it's about, of course, public standards, or even within the enterprise, right? Sometimes there's a canonical model for specific areas, and when you're integrating data from different departments, from different functions in your organization, this can definitely help. So yeah, that's
definitely. There were a couple of questions maybe that were fitting well here. One comes from Jesse, and he asks, are there pre-made ontologies for things like expense management or procurement that you've all heard of or seen? And I think this is another example that you discovered here. This Beamer.
My process has been
the Getty one.
The one that everyone will use. I type something like ontology catalogs, ontology repositories. Yes, there are some. I mean, there's there's some specific for life sciences, for pharma. It's hard. I mean, I don't think there's a single one. So you're gonna have to do inevitably a little bit of research. The other thing is that not always you get things like, how often are they updated, or even more important, how often are they used? Because that's, these days, we don't book a holiday, or we don't, buy a product if we don't see the reviews. That's so important, because, you don't trust. So if someone told me, hey, this building ontology not only looks rich and interesting, but there's 100 projects using it, well, that probably would, because I can look at the history. I don't know, the 0.1, I don't know how many versions have been published. We can look at that. This is from our friends at the Polytechnic. That's where I did my PhD, so I'm sure there's top quality there. But what I mean, these sort of elements would be so useful if we could tell that's how popular this is because people are rating it, or because people are using it, or well, unfortunately, I'd love to hear from anyone in attendance if they know where to take us, or where should we go in order to find this catalog. That would be fantastic. But best I've been able to do is Google and find some isolated.
That's probably what we all end up having to do. But if you hear anything, see anything, know of anything, let us know. Another good point is coming from Owen, where I think we talked about this before. We said, okay, what if you have like 2 or 3 different concepts you want to merge together, like in ontologies, and how do you do that? He asks, can you merge multiple input ontologies into the same graph? I think this model could be the same thing. You could add another. You can load another JSON from another completely separate ontology. Let's say a people concept and a product concept, and you can merge them together, and then you have the parts you're interested in your data set. And I think that's the point that I want to make to Meran, but maybe you have another comment here. And he asks, why not directly import the ontology in turtle format? Why do we have to transfer it to JSON format? I think the point here is you can do that, but what we're doing here is we kind of like drill down a little bit to the parts in the ontology that we are interested in. If you import you can do the full ontology, but if you just maybe 80% of that is not really relevant to your data. You care about the 20%, and then it's a map. You don't have to do the full.
Yeah, we're just. I don't really understand totally the question, because the RDF format is just a way of serializing it. So here I'm creating my ontology in this environment. In Neo4j, I'm using the ontology in this environment. When I exchange it, I can serialize it as RDF, which is the standard one. But this is the mechanics of how we do things. I mean, yeah, I mean, probably eventually, and I would be super happy if at some point in Neo4j we can just instead of having to do it through this intermediate step, I would be able to import here from an ontology and do it directly. But you know, it's a trivial step. I mean, I'm going to share the code, and you're gonna see how this is purely a simple step. It's not. I mean, I don't consider that relevant. I mean, what matters is that we can. I mean, an ontology is an abstract concept. Is a domain representation. How you ultimately use it is entirely problem driven and application driven. So. But yeah, let's get moving, because otherwise we're going to run out of time. And remember that we had created an ontology in Protege, and we had it in our. I wanted to show how this is generic and works on any ontology, but the one we want to work on is the sales ontology. So I'm going to take the URL, and I'm going to paste it here like I did with the others, and this is going to go and scan the classes, and we have all the elements that we saw before: credit notes, customer, etc., etc. In this case, I'm going to take them all, and this is going to produce the summary. And I just need to download. It's stored as sales ontology version 1, probably because I had a previous one here. And I'm going to create a new model and import the one that just been created, sales onto 1, 1636, which reminds me that we're short on time. But anyway, there you go. So this is our ontology loaded in Neo4j. And as before, I mean, I need to refine my layout, and I got some suggestions from Michael on which libraries to use. But basically, we have the key elements there, right? So we have as we saw, we have the store, we have the location, and the customers that are connected to locations. There's a credit note that's for a customer, for a purchase. There's the purchase is also connected to a product. So that's my ontology. And for each one of the elements, we have the different properties that we'll define in the ontology. So all good, nothing special here. So what I'm going to do, I said, this ontology is going to be driving my data ingestion, both from unstructured and structured data. Let's start with the structured one. And for that, we can browse let's go to my session 32. And remember, the CRM folder is the one that contains the 3 CSV files. So I'm going to open those, and we have them here. And all I have to do now is the mapping. And I'm going to try to do it as quick as possible. In the CRM data, I only have part of the model. So in order to run the input, I'm going to have to be selective here, and I'm going to say, okay, customers, I'm going to try to do it as quick as possible. Come from the customer table. I'm going to map so the customer ID is the key, and it comes from the customer ID field. The customer name comes from the full name, and the email comes from the email field. Boom, that's done. This one is done. Then there's a location coming from the locations table. The address, I didn't represent it properly. Let's take the street name for simplicity. And the location ID, it has an ID as well, which is the key. Another one that's done. Then the address can be extracted from the customer table, because there is a foreign key. There's a reference that connects the customer ID to the location ID. Oops. There you go. We don't have store information here, so we only have purchase information. So the purchases come from the purchases table. And again, there is the date is going to be the date. The purchase ID is the key and is coming from purchase ID. And the quantity is the quantity. And there's the card reference, card ID. There you go. So another completed. Now the connection between purchases and customers comes from purchases, because there's another foreign key there. So the purchase ID and the customer ID is down here. We also have products, and the products are just references in the purchases table. In the purchases information, as you can see, there's very, very limited information. There's just the product ID, which is 80. We'll see that the biggest part of the product information is going to come from the unstructured data later on. So we're going to have to combine that together. So the product, we have just the product code, which is going to be the key, and comes from product ID. And that's pretty much everything we have. So I'm going to have to get rid of, I mean, in the data importer here, when I cannot populate something, I have to remove it because otherwise it's missing data. So this is the purchase ID, and product code is going to be the product ID. And well, same here. So the credit note information is not here, so I need to remove that. And the store information is not here, so I need to remove that. So I'm ready. So that was quick. So I've indicated where the portion of the ontology that comes from the unstructured data maps. And once I have it, I can do a preview, and that's going to preload without writing to my Aura instance, and it's going to show me what kind of information I'll be loading, and that looks pretty cool. So we have individuals, right? This would be a person that's this is a purchase by a customer of a product, so it looks pretty nice and it's connected. So then, well, it looks more or less what I want. So I'm happy with that. So I would go ahead and import this, right? So we've seen how the ontology has driven the import of structured data from these tables or CSV files, but we had an important collection of data sources, which I'm going to. And sorry, I'm accelerating a little bit here. I'm going to show how to run programmatically from the. I don't have an interface for that, unfortunately, but it's pretty much what we did last episode. So you probably remember that we had these. We were using the knowledge graph. The GraphRAG package, and in particular, we're using the simple knowledge graph pipeline, which was a simple way. Let me remove these comments that are not needed here, but it was a simple way of specifying a complete pipeline. And the pipeline, if you remember, was indicating the sources, how to process them. In this case, they are PDFs, so they need to be parsed for the content to be extracted. We need to chunk it. We need to we need to split it. That's what the splitter defines. We need to use an LLM to embed some embedder service to embed. Remember that this knowledge graph builder created the famous two graphs. There's the lexical graph, the document graph, where we kind of chunk the source data, and we have it organized around documents with chunks, which then get vectorized, and we can use for one of the RAG retrieval approaches, which is vector-based. But at the same time, in addition to this kind of lexical graph, it builds the domain graph, which is the more interesting one, where it extracts entities out of the document. So it will go and identify, hey, this document mentions a product, and the product has this product code, so I can extract these entities. And the same in a credit note. The credit note is going to reference a customer, the customer. And guess what information I'm giving this pipeline to extract and to define the entities that I want? Well, exactly the ontology. So that's what I do here. If you remember from previous episode, I'm passing the entities, I'm passing the relationships, and I'm passing what we call the potential schema, which is the connections between entities and relationships. And where do I get that from? Again, the code has entirely been reused. So what I do is I get the schema for my ontology. So I'm saying, go get the sales ontology. And this code, this logic is here. The get schema from onto is in the RAG schema from ontology. Again, you have the access and you will have it again here. But it literally parses the ontology and takes the guidelines that the knowledge graph builder pipeline is going to use. So that these are the guardrails that indicate what kind of graph do I want to build. So without further ado, what I'm going to do is run it. And as you can see, I instantiate the knowledge graph builder pipeline. And all I do after that is call it twice. I call it to load the product descriptions. And basically, it's iterating over the files, the PDF files in the product description folder, which is in the data product description. So these are the PDFs. I had this filter to try with one example, the one that ends in 6, but I've commented that out. So we're going to run it for all of them. And the same with the credit notes. So I indicate that's the file, the folder where they are contained. So data.credit /credit notes. and it's going to iterate over the PDFs and just process them and run it. So like I said, I'm going to run this. Of course, as configuration, I've had to pass my, I'm using OpenAI here for the vectorizing and the entity extraction. So I have to pass, of course, my credentials. So all that is passed in environment variables, but nothing new here. So the important thing is, again, look at this in a couple of dozen lines of code, because there's not much going on here. All I'm doing, again, like I said before, specifying the LLM that I want to use, and some basic, and I literally use all the defaults. So if you go to the documentation, and let's go to it while it runs, because it was the GraphRAG package Neo4j. That's the documentation, and in particular, I'm using the knowledge graph builder and the simple knowledge graph pipeline. So that's exactly what I'm doing. So like I said, it takes a document, it loads, splits, it embeds, and then ultimately it does the entity extraction and writes to the knowledge graph. So that's what's happening as we speak. And as you can see, these are the elements that I've literally copy-pasted to my Python code. So if everything goes well, it should be now parsing these are the product descriptions. And we can see that as we speak, there will be something coming up in our Aura instance. I think I have another, here we go. So that's my Aura instance. So we might find, let's look at what we have here. So, okay, so this is a chunk. These pink nodes are chunks, and chunks are connected to, let's make it a bit bigger so that it's readable. So chunks come from documents, right? So there's a reference to the document, and the document have the path to it. So this is one of the PDF catalog documents. And a chunk is a fragment of the code. As you can see, it has the text and it has the embedding version of it. But look at that. It has extracted a product. So it's extracted an entity. And it's a very rich description of the product. So it has the product spec, as I describe in my ontology. It has the product code. It has the product details, the key features, the product name, etc., etc. And, well, because we're reading multiple files, actually, we can, probably the more interesting part is if I just load the products, because the chunks are probably less. But yeah, as we see, it's extracting little by little some products out of those. But yeah, for each one of them, it will be connected to the chunks where it was extracted, and the chunk itself will be connected to the document, and so on and so forth. So as we speak, it should be still loading now the credit notes. There you go. So it's done now, and we should have now. It's still not refreshed. Maybe we can reload that. And here we go. We have the credit notes as well. And the credit notes, as you can see, should be connected to a bunch of things. So
cool.
Can we? So the credit note, it has the credit note ID, as you can see here, the credit note date, the amount refunded, the refund reason. So it's done a pretty good job at extracting the entities. And it's connected to a person, to a customer. And the customer has the name, the email. And keep in mind that these things, and as before, these are the chunks that are a bit less interesting, but well, I'll keep them on the side. But we also have the refund for this. Let me get the chunks away to make it more readable. But look at that. So we have, and there's a location as well, right? So I was trying to, yeah, there you go. That's going to be nice. So this is a purchase, and we're going to have the purchase ID, for example. And there's the customer, and this would be a credit note that can be, I don't know, the refund amount. Yeah, because it has multiple labels, sometimes it behaves in a funny way. But anyway, we have the kind of, how do we call it, the lexical graph, which are the chunks, And then we have the domain graph that now magically, because it's aligned with the ontology, because look at this. I mean, this at location, refund for, issued for, the notion of a purchase, the notion of the category location, the category customer, the category credit note, all these, where do they come from? Well, they come exactly from the ontology that we just defined, right? So all this was already there. So when I now run the input, which I just ran a preview before, this is going to take only a few seconds, hopefully, boom. Now the two elements are combined, and we're going to see how the full graph is the result of importing the structure and unstructured data. How can we test it? Well, we can try to build a pattern that wouldn't have existed otherwise. So if we have a credit note that's issued for, or how did we call it? A credit note is a refund for, which is the one that connects to a purchase. Refund for, this will be a purchase. And then a purchase will be connected, if we look at our diagram, a purchase will be connected to a, for example, a customer. How can we try to get some information that would combine data from the two different sources? Let's try that. So the purchase is was the relationship has address. That's not the one I wanted. What was the? I have it in my model. By customer. So that would be the proof. So if it's by customer, and we get to a customer here, let's put these in a subgraph. And let's return just 3 of them. Is there any error there? Maybe there is, we'll find out. There you go. So these are 3 small fragments where we see the two things combined. So we see a credit note for a purchase, and by a customer that comes from the CRM data. We can expand this and we'll see other orders by the same customer. So we see how things are linking together nicely. And then we have also the address for the customer. So data that comes from the unstructured source, which is the credit note, links to a purchase, that links to a customer, etc., etc. So I know I've been a bit quick, but I hopefully have made the message clear, because the important thing is that the same ontology that I created only once has driven both the ETL, or the structured data ingestion, into the property graph, but also, and that's what we've seen programmatically, probably, you have to believe me here, you've seen it running, but now you're going to be able to get your hands on the code and try it yourself. Because, the powerful thing here is that it's so easy for you to go and take and apply it to your own domain. So you go create your ontology and then use it to drive both types of inputs, and you'll see how it works. Now, just to conclude, and I realize that we have just a couple of minutes. We said at the beginning that some people might say, hey, that's not what I wanted to show, as always. So some people might say, hey, you've started here, you went here, then you went this other side. But what if I want to skip this step completely and create my model catalog? Well, that's entirely fine. So as you can see, once you have your model created in Neo4j, well, very briefly and very quickly, I'm going to show how you can, and this is just preliminary code. I need to, that's RAG schema from onto where was it? DI model parser. I think that's the one. So I haven't finished, but I'll finish before I submit it to GitHub. But one thing I can do is, okay, you've created your model in Neo4j. And in this case, that's an example that I have here called dealer for the other example, which is a simple model that contains, well, a car dealer is customers, cars, and I don't know if it's leasing or purchase of cars, but a very simple model. So you just save it from Neo4j, and you can just pass this logic over it, and it will convert it into, oh, no, that's not what I wanted to do. It's running again the data input, which I didn't want to run. I want to run the DI model parser. That's the one. So I closed it. So if I run this, it generates immediately the RDF serialization, the total serialization of that model. So it creates, like I said before, I'll complete it, but it's my way of proving that we do effectively close the circle. It doesn't matter where you start. You can have your ontology in whatever starting point, and you will be able to use it in any environment. So I'll take a break here. I hope it made sense. It will make more sense when you have the code available, which will be in the coming minutes. But let's take the remaining 5 minutes for Q&A. There, Alex.
Yeah. No, that was very cool and very, very interesting to see how easy it is to get that data in, and then to model this in a way, or from starting out with the model, helping out the modeling with the ontology, and then getting structured and unstructured data connected to your graph, and to building up the knowledge graph in that fashion. So that was cool overview. So thank you very much for that. There was one question from John, and he asks, how do constraints by ontologies work with constraints by Pydantic?
Okay, that's a good question, because there's things that and this takes me to these kind of misunderstanding sometimes with ontologies. Ontologies are descriptive artifacts. So in reality, ontologies are not necessarily the same thing as the constraints that you can define in Pydantic. So the closest equivalent to what you can express in Pydantic would be described in vocabularies like shackle, which we've talked about also, if we want to use one of the W3C standards. So for example, if you want to say, this entity has to connect to at least one, but no more than two. For example, the parent, the parent relationship. So a person will have two, but no more than two, at least, in a traditional definition so you can specify these kind of things with a constraint language like shackle, but not necessarily all of those with ontology languages. So ontology is more aligned to what we understand as a schema. Things like, the format of a property of an attribute. You can apply a regular expression and saying, well, the format of a telephone number has to be this one. This is the kind of thing that's the traditional constraints, what you express in Pydantic, and that you would describe in shackle in the RDF world, but it's not necessarily comparable to ontologies. So to your question, you would not be able to express with an ontology the kind of things that you express with Pydantic. Basic things, yes, like things like a primary key or things like that, yes. But if you go beyond that, that's not possible.
Okay. Yeah. And then another question from LinkedIn. Can you modify the ontology within the Neo4j environment? I think we showed this a couple of times before.
Yeah, absolutely. Yeah. So once you import the ontology, you can extend it, you can remove elements. I mean, you can and then you can persist it in the Neo4j environment, and then from there you can. I mean, it all depends on what kind of life cycle are you implementing, right? Do you want to revert back to the W3C version of the ontology? You could do that with what I showed in the last step. Maybe you want to implement the changes maybe have one master. I mean, you have to figure out which is the environment that you're going to be using to kind of version an ontology, and then probably use the rest as derived from it. But yes, you can. The quick answer is yes, you can modify it, and then it's up to you to define what's the life cycle of the ontology and which is the master of it.
Yeah, absolutely. Cool. I don't think I see any more questions. I missed any. If I missed your question, then sorry. Sorry for that. No. not on purpose. I wanted to obviously say thank you very much, Jesus, for this demo today. I think this is clearly one of those where, like Praveen says, lots of learning, great workshops. So it's really great to see if you, from the concepts, from the ideation of how we talked about this in a couple of episodes before now. Basically, you take an ontology, take a data structure, model that into a graph structure, and then import your data, structured or no, and then you have a knowledge graph from that. Very easy, very quickly done, and also you don't get into all these issues you sometimes could be getting into by letting it all. We did this before. Obviously, everything is done by an AI model. You could do it this way, but this is more structured, and this, as we could see, is less error, much less errors. Indeed, I think we had a good showcase here for this to, everybody can do it, and it's very little work, and it gives you probably more reliable results in the end as well by doing it like this. So next episodes, 22nd of January. So in 2 weeks' time, we do entity architecture for efficient RAG on graphs with Irina from Accenture. So I'm looking forward to this discussion in 2 weeks' time. So if you're interested in that entity architecture, we did also a little bit of I think almost a sideline topic to one of the previous episodes here, where we talked about entity recognition. So I think this is a good topic here. We are still running our developer survey. It completes, I think, in a couple of weeks. So if you are interested in giving us your feedback on how you work with data, how you work with Neo4j or graph databases, then let us know. We would be happy to get your feedback in. And as always, if you are interested in taking the next steps, I mean, Aura we showcased today in this episode. So if you want to create your own models in Aura, then click on this link. Or learn more about Neo4j in general in the Graph Academy, and the community is always there for you. So check that out. And I think with that, I think we're at the end. Sorry, Dirk. I think maybe, I don't know. Do we have one more time? One question for? Do we have more time for one more question? Jesus is the question.
Absolutely.
Yeah. So okay, then Dirk, we do yours now. Dirk asks, what about decision rule engines, SAT solvers, back and forward chaining rules? Is that something?
Absolutely, and that's great, because we end with a reference to a previous episode. So I would say the one I would recommend is I think we call it Reasoning 101 in many months ago, but it was a great example of how, I mean, again, today ontologies were kind of canonical,
episode 4,
the way we structure data. But there's another use that, in order to guarantee interoperability, reuse, etc. But there is the other use of ontologies that we've talked a lot, which is inferencing. So ontologies can be more advanced and capture information that can be used to do sophisticated tasks. So this was covered many times, but I can think probably as a starting point of these. I mean, I could look it up, but I think it was called something like Reasoning 101 or something like that.
Yeah, so, the Reasoning 101 episode was episode 4. So that was I can link it in chat here.
Perfect. So there should be more, but that would be a good starting point. So
Cool. Tools to go from SQL databases to ontologies.
I mean, I don't know if what you mean is because an SQL database has the data and has the DDL, the schema. So if you want to distill an ontology out of it, if you want to map a database to an existing ontology, we've touched a little bit of that in again, let's look at the episode. I mean, this was not a tool; it was an LLM-based approach where we took a relational schema, a denormalized big fat table, and we kind of distilled an ontology out of it, a schema model. So that was in season 1, something like
Was it episode 25, LLMs for automated knowledge graph construction?
Yeah,
was that the one?
That could be one. So that was an approach, a programmatic approach using LLMs. But there are tools out there. I mean, we've mentioned before Data the World. I mean, they I don't know if they include that recently, but I think the way they published their benchmark was based on this idea of overlaying an ontology with a mapping. It's a pretty complex approach, but you can map the source to the source data to an ontology. So there's tooling out there. I don't know if that's what you mean, or if it's something different when you say SQL to ontologies. Please send us a note, and we can take these offline.
Yep, absolutely. The 2 episodes we just mentioned, I have added to the video notes with the video description in YouTube. So you find links there. You find also in every video description, you find all the links to all the previous episodes in one big page. So you can check out what we covered already in the past. And also there's the link to the GitHub repo that Jesus mentioned earlier. So if you want to check out what we have shown you today and you want to try it out yourself, then give it a bit, maybe check it out tomorrow or so. And then it should be in there in the repository, and you find everything you need to replicate the demo from today yourselves. And that's it for today. So yes, thank you very much for watching. Thank you for your comments and questions. As I said initially, if you give it a thumbs up on YouTube, then that helps us a lot. Share the series with friends or colleagues, and let us know if you want something else, if you have a topic you'd like to discuss, or if you have any other feedback. Always open for hearing your thoughts. And with that, Happy New Year again. Hope you had a good start into 2025. See you soon somewhere around the Neo4j world, if not on the 22nd for the next Neo4j live stream. Until then, have a good day, rest of the week.